For this page for implicit differentiation, let's take a look at number 2. If you need a little extra practice, you can do number 1. Number 1 and 2 are similar, except for that number 2, we're going to do one more step. And after we find the derivative, we're going to evaluate it at the ordered pair 1, 1. All right, so find the instantaneous rate of change. That just means find the derivative. Find dy dx. So you never know how they're going to ask you to find the derivative. In example 1, they didn't use words. They just used the symbols dy over dx. Okay, so I'm going to bring in the derivative operator. And noticing that in this middle term right here, we're going to have to do the product rule. All right, so for each of these terms, let's find the derivative with respect to x. So we have 1 plus, I'm going to go ahead and do a bracket here. Okay, so the product rule, I'm going to go ahead and take the 2 with the x and call that my first factor. So it's 2x times the derivative of y with respect to x, plus the second factor y times the derivative of 2x, which is just 2. So that's just plus 2y. So brackets weren't really necessary because I didn't have a subtraction here, but it's kind of a good habit to get into. All right, let's find this derivative with respect to x. So just differentiate, get 2y, but multiply by dy dx. Derivative constant is 2. All right, so these brackets are no longer needed. I'm going to gather up the dy dx terms and send everything else to the other side. Factor out the dy dx. Divide both sides by 2x minus 2y. All right, so to find the instantaneous rate of change, that means that we had to find dy dx, and then we're going to evaluate at 1, 1. So we're looking for a value. Right here, I could have plugged in 1 for x and 1 for y, and then found dy dx. Or you can wait till the end and plug in 1 and 1. Your choice. Sometimes it doesn't matter. Sometimes one method's easier than the others. Oh, interesting. All right, so the numerator would be -1 minus 2 or -3. And the denominator is 0. So it's undefined. So we have a vertical tangent line. That's interesting. Okay, so there is no instantaneous rate of change. It doesn't exist because there's a vertical tangent line to this curve at that point 1, 1. All right, so let's take a look at number 3. All right, we have equation of a circle. What is the value of the second derivative at the point 4, 3? So we've got to find the second derivative and plug in this x and y. With respect to x, we're going to have 2x plus 2y dy dx equals 0. All right, it's not time to plug in 4 and 3 yet. Let me find the second derivative. I could find the second derivative at this point, or I could go ahead and isolate dy dx and then differentiate again, which I think that's what I'm going to do. So look at that. Divide both sides by 2y. All right, so that's the first derivative. Let's find the second derivative. So you bring in that derivative operator again. Okay, that's going to produce the second derivative of y with respect to x a second time. You could bring the y up with a -1 exponent, do the product rule. I'm just going to go ahead and do the quotient rule. Remember, we're differentiating with respect to x. So, and the answer of the quotient is the denominator squared, and I start the numerator of the answer of the derivative with the denominator. So, denominator times the derivative of -x, so that'd be -1, minus the numerator times the derivative of the denominator, which is dy dx. So I can change both these signs in here. Maybe a little bit of cleanup. -y, those both change, plus x dy dx over y squared. Okay, so now it's time to plug in values for x and y, and you have a couple of choices on how you want to handle dy dx here. You could replace it with -x over y, or you could come back up here, which I think I'm going to do. Okay, and I'm going to go ahead and evaluate that derivative at the given point. Now's a good time to do that. So this would be 4/3. So -4/3. And that'll go in here. I'm going to evaluate that at 4,3. So -3 plus 4 times, what was it? -4/3 over 9. Okay, so let me kind of come across here. -3 minus 16/3 over 9. You're done and finished. I mean, it's not very pretty looking, but what you could do is you could multiply everything in that problem by 3 to clear the fractions. So if we think about taking care of this complex fraction situation, if I multiply by 3/3, a form of 1, I'm multiplying everything in the top by this 3 and everything in the bottom of this fraction by 3. I'm going to get, looks like -9 minus, that 3 is going to cancel with that 3. I'm distributing here. 16 over 27. It looks to me like -25 over 27. All right, so we just did 2 examples. I don't think it's necessary to do example 1, but as you can see right here, what's probably going to be the most challenging is this middle term right here, finding the derivative using the product rule. Okay.